Today we're going to be looking at absolute value equations and inequalities. So what we have to do, we're going to end up splitting this absolute value into two equations. And the reason why, absolute value says whatever you have on the inside, make it positive. So that means that 2x plus 1 was equal to positive 7 to begin with, or 2x plus 1 was equal to negative 7. Now, the key here is make sure the absolute value is by itself. We're going to see an example of that in a little bit, but we're going to split it into two equations. Now, solve for each variable. In the first one, let me subtract the 1. So 2x is equal to 6. Now divide both sides by 2, and x is equal to 3. Same thing here. Let me start by subtracting a 1. So 2x is equal to negative 8. Divide both sides by 2, and x will be negative 4. On a number line, I'm going to find negative 4 and positive 3. If it's not labeled, label it as you need to. And my answer will be the 2 points, 3 and negative 4. Now, what we mean with solution is any of these two values of x, if we substitute it into our equation, that statement will be true. Now, let's take a look at inequalities. Same thing, kind of like how we did with equations. We're going to split it into two questions here. My first one, I'm just going to go 2x plus 1 is greater than 7, just as I see it without the absolute value bars. Now, my other inequality I'm going to solve is 2x plus 1 is less than negative 7. So notice I flipped the sign and I flipped the arrow and I changed the sign of my number at the right. Now solve each inequality the way we always do. Let me subtract 1 on this one. So 2x is greater than 6. Divide both sides by 2. X is greater than 3. Looking at this other one, let me subtract 1. So 2x is less than negative 8. Divide both sides by 2. X is less than negative 4. So I find my numbers 3 and my negative 4. Now, on the first inequality, x is greater than 3. Basically, I'm saying any number bigger than 3. So there's many numbers. Because my inequality, it only has the arrow, it does not have the or equal sign, I'm going to say it is a parenthesis. If it had the or equal sign, I will say it's a bracket. And I'm going towards the right. Anything bigger than 3 is towards the right of it. Now, x is less than negative 4. It's also a parenthesis, but this one goes towards the left because x is less than. So any number in those arrows will make the statement true. Now it's going to ask us for the interval notation. Looking at my graph, I ask myself, how far left do I go? So looking at the first one, how far left do I go? I go as far left as negative infinity. And then I stop at negative 4. On that arrow, where do I stop? So I stop at negative 4. Looking at the other arrow, I'm going to say, how far left do I go? I go as far left as 3. How far right do I go? I go as far right as positive infinity. So I have two sets, but I want to say that they both are solutions. So I'm going to say the union of those two sets. Same thing here. Let's take a look at this one. 2x plus 1 is less than 7. 2x plus 1 is greater than negative 7. Before I continue, I want you guys to go to the previous example. See how my inequality sign was greater than. Now we're doing less than. We're going to see what happens. All I did was change the sign, the inequality sign. So let me subtract the 1. So we have that 2x is less than 6. Divide both sides by 2. X is less than 3. On the other one, let me subtract 1. So 2x is greater than negative 8. Divide both sides by 2. X is greater than negative 4. So my important numbers are 3 and negative 4. If I was to look at the first one, x is less than 3 gives me that. X is greater than negative 4 gives me that. Now, when we have that less than sign to begin with, I'm going to say my solution will be the intercept of these two arrows. So it's going to be from negative 4 to positive 3, anything in between. Now, as an interval notation, I ask myself, how far left do I go? I go as far left as negative 4. How far right do I go? I go as far right as positive 3. So that's my interval notation. Now here we have an equation, but the absolute value is not by itself. So I have to get rid of the 5 to get the absolute value by itself. So I have that absolute value of x plus 3 is equal to 7. Now that I have it by itself, that's when I'm going to split it into two equations. X plus 3 is equal to 7. X plus 3 equals negative 7. On the first one, let me subtract 3. So x must be 4. On the second one, let me subtract 3. X must be negative 10. Once again, get the absolute value by itself before we work on it. So let me subtract 5 on this one. So I have the absolute value of x plus 3 is greater or equal to 7. Now that I have it by itself, I'm going to split it as x plus 3 is greater or equal to 7, x plus 3 less than or equal to negative 7. Let me subtract 3. So x is greater or equal to 4. Let me subtract 3. X is less than or equal to negative 10. Looking at the example B, let me subtract 5 on each side. So I have the absolute value of x plus 3 less than or equal to 7. So I'm going to split it as x plus 3 less than or equal to 7, x plus 3 greater or equal to negative 7. Let me subtract 3 on each side. X is less than or equal to 4. Let me subtract 3 on each side. X is greater or equal to negative 10. If I had to graph these, my first one, my numbers are 4 and negative 10. I have a bracket of 4 and I go towards the right. I have a bracket at negative 10 and I go towards the left. If I had to do interval notation, I ask myself, how far left do I go? And I get to negative 10. On the other one, how far left do I go? And then how far right do I go? And I want the union of both. Looking at my example B, here I have 4, here I have negative 10. I'm going to do bracket of 4 and I go towards the left. I do a bracket at negative 10 and I go towards the right. So in this case, I get everything in between. My interval notation, how far left do I go? And then how far right do I go? Notice how my answer when it came to interval notations or the graph, how they change. And to be honest, the difference on the two questions is just the inequality symbol.